Hey guys, welcome back to a new video, and in this video I'm going to show you how you can use Dagger Hilt dependency injection framework into your Android project. So without wasting any time, let's get started. What is dependency injection? Dependency injection is a design pattern in which an object receives its dependency from external source rather than creating them by itself. Now, Dagger is a fully static compile-time dependency injection framework for Android. It uses annotations to define dependencies and generate code to handle dependency injection. Dagger Hilt is a top-notch thing of Dagger. It built on top of the Dagger. It is very easy to use. So let's get started with our project and see how we can actually perform dependency injection. So first thing first, go to my GitHub repository, download the project and open up into your Android Studio. Link is in the description box. So in this project, I have already given you all the dependencies. So we have here all the dependencies. On the top, we have Dagger plugin and KAPT annotation processor. So this processor is actually used to process our annotations that we will use in our project. Open up your build Gradle KTS of root level, add this plugin. Alright, so first thing first, it is a good time to set up Dagger Hilt dependency injection framework in our project so that we can use dependency injection. So to do that, first thing first, create a class and the class name is base application. This is a class and this class extend application. On the top, simply use here Hilt Android app annotation. Register this base application in your manifest. Within your application tag, use here name property and mention your base application, and that's it. So it will simply initialize all of the basic things that we want in order to use Dagger Hilt dependency injection framework in our project. Cool, so let's begin with our dependency injection things. So first thing first, let me create package. Name is model, and in this model I'm gonna create a data class and the data class name is engine. In this engine we have name, type of this thing is string. Now I want to inject this engine in my main activity. So to do that, first we have to use here Android EntryPoint. So this annotation is used to tell our Dagger that I want to perform dependency injection in this class. Now it's time to perform injection. So for that we have one annotation naming inject. Latent variable engine, because it is initialized lately, that's why I'm using here latent variable. But we have a problem, and the problem is this engine is something which our Dagger Hilt doesn't know how to create. We will tell Dagger how to create instance of engine, but before that use this engine name in here. Okay, so now it's a good time to tell our Dagger Hilt how to create this engine object. So for that we use modules. We have a package name is module, and in this module I'm gonna create an object, and the object name is app module. I want to install this thing in singleton component. Just be with me, I will explain you everything regarding the component. It's a most important thing to know. Next we have here module annotation. So this module annotation is actually used to tell Dagger that this is a module, and this module contain a few logic to generate few certain objects. Now we have here provide annotation, function provide engine. This provide annotation is used to tell Dagger that this is a function that will give you or provide you some object. Use here engine, return an object of engine. Name of this thing is app module engine. And yeah, we are pretty much done. Now our Dagger Hilt knows how to create engine object. So it will simply uses this logic, build an object of engine and inject that thing in our main activity. Simply execute it to see whether it works or not. There we go, it works. Hello app module engine. Provide annotation is also used when you want to generate every time a new instance of the object from dependency graph. Now let's say I want to create only one instance of engine and want to reuse the same instance again and again. On that case, you can simply use here singleton. So what it will do, it will simply create only one instance of engine, and in future if you want the dependency of engine from your dependency graph, it will simply uses the previous instance that you have been created already. If you haven't created yet, then it will simply create one new instance for you and use the same instance again and again in future. So this is a use case of singleton. You can use singleton with database instance, retrofit instance. So basically, if you want only one instance, you can annotate your function or your data model with singleton annotation. Now it's a very good time to discuss what is singleton component and we have other components or not. Yes, we do have a lot of components. We have singleton component, we have activity retain component, we have activity component, and we have view model component, fragment component, service component, view component. So that means we have a lot of component. This component act as a container, and that container is tied up to a specific lifecycle. So singleton component tied up with application lifecycle. Once your application got destroyed, then only all of your module that you have been installed in this container will be destroyed. Similarly, we have activity retain component. So activity retain component lifecycle is totally attached to the activity lifecycle. Similarly goes for the activity component. What is the difference between activity retain component and activity component? The main difference between them is activity retain component will simply survive the configuration change. It won't create your modules again when you change the rotation of your device from portrait to landscape or vice versa. But in activity component, it will simply recreate all of your modules that you have been installed in activity component. So this is the main difference between them. Then we have view model component. So view model component is totally tied up with view model lifecycle. Similarly, we have fragment component. That means fragment component lifecycle is totally tied up with fragment lifecycle. Then we have view component. So view component lifecycle is tied up with views lifecycle. Lastly, we have service component. So similarly, service component lifecycle is totally tied up with service lifecycle. So this is a very simple way to understand what are these components. What is the use case of this? Well, suppose you want to create few dependencies that you want to inject only in view model. Then you can use view model component instead of singleton component. And we do have a relation between these component. All of the component is related with parent-child relationships. So on the top, we have singleton component that has two different child, activity retain component and activity component. Activity retain component will have one child naming view model component, and activity component will have three different child, fragment component, view component and service component. Now let's say you install one module in your activity component, then this dependency is only accessible by activity component, or you can say in activity, or by your child. You can't access this activity component thing to your singleton component until and unless you are in the activity. I think the logic is very clear to you. So child component will actually access the parent component dependencies very easily, but parent component cannot access the child dependency. So this is a very simple rule of getting the dependencies. I'm using a singleton component. Okay, singleton component will behave as a parent of every component. Now let's say I will change this thing from singleton component to activity component. Now activity component is a child of singleton component. Now let's execute our application, see whether it works or not. It is working because we are injecting engine into our main activity, and our app module is installed in activity component. That means this module lifecycle is totally tied up with main activity lifecycle. Due to that reason, we are able to perform dependency injection of engine. Now what will happen if I change this activity component into view model component and execute it? As you can see, it won't work because view model component child of our activity retain component, and child dependencies you cannot use in your parent, and due to that reason we are not able to perform here dependency injection in our main activity. Now simply change this thing from a view model component to activity retain component and it works, as you can see over here. Now I'm gonna show you how Dagger Hilt actually resolve dependency. So we have a very simple graph over here, or you can say flowchart. So on the top we have singleton component, then we have activity retain component, activity component, and below to our activity component we have two different components, fragment component and view component, and at last we have view model component. So let's understand this graph with a very simple example. So initially we are using singleton component on top of our app module. That means our app module is present in singleton component container. Now you can use engine dependency in everywhere because singleton component will be act as parent to all of our component. Due to that reason, we are very easily inject engine in all of your components. But what will happen if you change this install in singleton component to fragment component? On that case, you cannot inject engine in your main activity because child dependencies cannot be injected in your parent components. Due to that reason, it is not possible to inject engine in your main activity when you are installing your app module into fragment component. I think the logic is very clear. So you can use this component to make your modules very flexible so that it occupies very less memory. Now we will discuss how we can use bind annotations. So for that, we require two things. We require an interface and its implementation, and we are going to bind this interface with their implementation. Let me create a different package naming binds, and in this bind I'm gonna create an interface naming bind interface. So bind interface will have one function naming hello. A return type of this thing is string. Just below to it I'm gonna create a class naming bind interface impl. Use here constructor injection. So inject constructor. So what it will do, it will simply add bind interface implementation in the dependency graph. Now I want to write implementation for my bind interface. Simply press Ctrl I and override hello. Now in this I'm gonna return here hello binds interface. Okay, so now it's time to create a module, and the module name is binds module. This is not an object, it's an abstract class. On the top I'm using here installing, and I want to use here singleton component class. Use here module annotation to tell Dagger Hilt dependency injection framework that this is a module. Now it's time to use here abstract function bind interface, and in its parameter you can pass your implementation class. So we have here bind interface implementation, and return type of this thing is bind interface. On the top simply use bind annotations. Now it's time to inject bind interface in our main activity. So for that I'm using here inject latent variable of bind interface. So we have bind interface instance over here. Simply use hello function, execute our application. Here you can see hello binds interface. So using binds annotation, you can actually map your interface implementation. Now it's time to see how we can perform dependency injection in our view models. So for that, let me create a package, and the package name is ViewModel. And in this ViewModel, I'm gonna create a class, and the class name is main ViewModel. It's a class, so because it's a view model, we have a special annotation for view model naming hilt view model. Extend this class with view model. Now I want to perform injection in my main view model. So for the injection I'm going to create one more model class. So in this model we have a data class, and the data class name is transmission. We have name in it. Okay, now simply go to your main view model, and here I'm gonna use constructor injection. So usually in view model we use constructor injection. So inject constructor, and in this constructor I'm gonna perform dependency injection of transmission. Just below to it I'm gonna create a variable. Name of this thing is transmission. It's a mutable state flow. Initial value of this thing is transmission, and in place of name I'm simply using here empty string. And in its init block I'm going to simply update my transmission value with the incoming transmission from the constructor. Now it's time to create module for this thing. So let's do that. Now this time I'm using here object, and the object name is ViewModel module, because I want to perform injection in my view model. Due to that reason I'm going to use here ViewModel component, and this is a module, so simply use here module annotation. In this object we have one provide annotation that has a function which will actually provide us transmission, and in place of name I'm gonna use ViewModel transmission. Go to your main view model. Now it is injectable. So let's use this main view model in our main activity. So open up your main activity, and here I'm gonna initialize my view model first with the help of hilt view model, and type of our view model is main view model. We have here transmission, and I'm gonna collect this thing in a form of state. So view model transmission collect this thing in a form of state. Use this transmission instead of binds interface. Transmission name. Okay, let's execute our application to see whether it works or not. But before that, this hilt view model is actually coming from this dependency. Cool. So let's execute our application. Okay, so here you can see hello view model transmission. I'll show you how you can use constructor injection in your model classes. So for that, in the model, I'm gonna create a data class, and the data class name is car. In this car, we have two different dependency. We have engine dependency, then we have transmission dependency. Now, because I want to use here constructor injection, use here inject constructor. Import this inject. Go to your main activity, and here I'm gonna inject that thing in a form of field injection. So inject let it var car. Use this car in our greetings. So car dot engine dot name. Execute it. Okay, so we have a problem, and the problem is when you open up this car model, we have two dependency, engine and transmission. So engine is coming from our app module, and it is installed in singleton component. That means anyone can access this thing, whether you are present in activity component, activity retain component, fragment component, view model component. I mean, from everywhere you can access this thing. Next, we have view model module. So view model module is actually installed in view model component. That means you can only access this thing in your view model. Due to that reason, we are not able to inject this transmission object into our car. So if you want to inject transmission into your car, you can simply go to your app module and create one more provide function, which will provide transmission. Return type of this thing is transmission, and it will simply return an object of transmission. Name app module transmission. Now execute your application to see whether it is works or not. It is not working, and the problem this time is we have app module that is installed in singleton component container that has a one dependency transmission. Similarly, when you open the view model module, it has the same type transmission. In our dependency injection graph, we have two different transmission. Because of the same type, Dagger Hilt does not able to decide which dependency you want to inject in this car. And this is a problem. If you want to resolve this problem, you can use here a named annotation. So let's see what is the use case of named annotation. So we'll use a named annotation when we have same type of dependency in our dependency graph, and you want to inject those dependency in two different places. So if you want to do that thing on that scenario, you should use a named annotation. So named, I'm having here app, because we have two same type transmission present in our singleton component app module, and this transmission is also present in view model component view module. But in our car, I want to access transmission which is coming from app module. So just to make a differentiator, I'm using here named annotation. So let's use that thing. Go to your car, simply use here named. Value of this thing name is app. Now execute your application, but before that, just clean the project and execute. As you can see, this time we don't have any problem because our Dagger Hilt will simply use this named annotation and its value to make a differentiator between the same type of transmission. So this is the use case of named annotation. Now we will see how we can inject our dependency lazily. So to do that, you can simply wrap your type with provider. Next, here in place of name, I'm gonna use my engine. Get my engine, access its name. Execute your application to see whether it is working or not. Yes, it is working. So by using this approach, you can initialize your dependency lazily. Next, I'm going to show you how you can pass few parameters in your view model during runtime. So to do that, I'm going to create a class, and the class name is assisted view model. This class will eventually extend view model to inherit all of the property of view model. In its constructor, I want to inject engine. Next, I want to pass value during runtime, and name of this thing is user ID. This dependency is coming from our dependency injection graph, and this is coming during runtime. So because this is coming during runtime, you should annotate this thing with assisted. Okay, and this time this is not a normal constructor injection, it's a assisted constructor injection. Okay, so if you want to pass this thing during runtime, to do that you can simply create an interface, and the interface name is assisted ViewModel interface. Create a function, and the function name is create, and the requirement of assisted ViewModel is user ID, because this user ID is coming in runtime. Due to that reason, I'm gonna pass this thing over here, and a return type of this thing is assisted ViewModel. Annotate this thing with assisted factory, because this interface will eventually act as a factory, and this factory is able to create our assisted ViewModel. Now in this I'm gonna create UI state, mutable state flow. We have empty string value. Next we have UI state. Eventually it uses the UI state and convert that thing into state flow, and in its init block I'm gonna update my UI state with initialize string. Now it's time to use this assisted ViewModel. So first we need to initialize this thing. So for that, go to your main activity, and in the main activity I'm gonna add a field injection. Late init variable, we have assisted interface. Assisted, so we have factory, so use assisted ViewModel interface because it acts as a factory. So by using this factory you can actually create this assisted ViewModel. Now go back to your main activity. I'm gonna create assisted ViewModel naming parameter. Initialize this thing with assisted interface dot create, and in place of user ID you can pass my name. Cool, we have UI state coming from assisted ViewModel dot UI state. Collect this thing in a form of state. Now use this UI state over here. UI state, execute your application to see whether it is working or not. As you can see, our application is running. That means user ID Himanshu will be passed successfully. Let's see whether it is properly working or not. So for that you can simply use your assisted ViewModel dot user ID. So in order to access this user ID, you should go to your assisted ViewModel and make it available. Come back to your main activity, use here user ID and re-execute your application. You can see hello Himanshu. So by using this approach you can pass your parameter during runtime into your view models. So what is the meaning of assisted inject? When you want to inject few dependencies from your dependency graph and few dependency during runtime, then you can use assisted inject, because this user ID is coming from the user during runtime. Due to that reason, I'm using here assisted annotation in front of this member variable. So now we will discuss component and subcomponent annotation in Dagger Hilt. So let's say you want to perform dependency injection in a component where Android entry point won't work. So for example, we have custom content provider, and in this content provider, if we want to inject engine, it is not working because Android entry point won't work in here. Android entry point is only work with activity, fragment, service and broadcast receiver, but it won't work with content provider. How can we inject engine in this custom content provider? So in this scenario you can use component and subcomponent, or you can use entry points. So let's discuss the both approach. So first let's begin with our component and subcomponent approach. So first let me create here an interface, and the interface name is parent component. Annotate this thing with component. Just below to it we have one more annotation naming subcomponent interface, and I'm gonna call this child component. Now in this child component we have function naming inject, because we want to perform dependency injection in our custom content provider. Due to that reason, in this inject we have to pass one parameter, and the parameter name is custom content provider, because we want to perform DI in custom content provider. We have one more interface naming factory function create. So this factory function is actually used to build child component. You should annotate this thing with subcomponent dot factory. Go to your parent component, and this parent component will eventually return the implementation for this factory. Create a function, and the function name is child component factory. Return type of this thing is child component dot factory. So we are pretty much done over here. So first we have parent component, then we have child component. Responsibility of parent component is it will write the implementation for our child component dot factory, and with the help of this factory we can actually create an instance of our child component, and once we receive the child component instance we can simply perform injection. So this is a very simple flow of this component and sub component, and in this component you can actually mention the module where to look to get the dependencies that you want to inject in your custom content provider. So in our use case we'll use here application module class. So this approach will work when you have more than one modules, but for our use case we have a single module, so it's very easy. We have our app module, so if you want to look any other place you can mention that thing in here. So we have both places in which you can pass the modules, I mean where to look to receive the dependencies. Okay, so now it's time to go to your base application, but before that just clean the project and rebuild it so that it will generate all the required code. So in our base application I'm gonna create a variable, and the variable name is parent component, and I'm using here lazy block. Now in this we have dagger parent component dot create. So what it will return, if you can check the return type, we have here parent component. That means it will give us the implementation of our parent component. Now it's time to use this thing. So go to your custom content provider, and in this on create just use context, grep the application context and typecast this thing with base application. We have parent component that contains child component factory. Now we have factory implementation. This factory implementation will have a function naming create, which will create child component. Now we have child component have one function naming inject. So simply use this inject and pass your instance, which is this. By using this it will eventually initialize your engine. So use here inject latent variable engine, and I'm gonna use my engine over here in the logcat so that we are able to see engine dot name. Just use here big tag. Go to your main activity, and in our main activity I'm gonna use content resolver to invoke my custom content provider. So content resolver dot query, and in place of URI go to your custom content provider. This is our content URI. So go to your main activity. Instead of using this you can use custom content provider dot content URI, and in other place you can simply pass null. Okay, cool. So now I'm gonna execute my application. Open up the logcat, delete everything. As you can see in our on create we are receiving app module engine. That means in our custom content provider we are successfully injecting engine. So this is the first approach using which you can perform dependency injection where Android entry point won't work. We have one more approach, and that approach will actually use entry point. So let's see how we can use that thing. So for that I'm going to create a file, and the file name is EntryPoint method. In this file we have an interface name is EntryPoint method that has one function naming get engine. A return type of this thing is engine, and on the top I'm using here install in. So I'm going to install this thing in our singleton component or singleton container. Next you should use here entry point annotation. Clean the project and rebuild it. Open up your custom content provider. So instead of using this I'm using here entry point accessor from application. So requirement of this function is context. So simply pass your context. Next we have to pass the entry point class type. So in my case we have entry point method class.java. So now we do have our entry point in this variable. So use your entry point dot get engine to receive the engine. Cut this thing out from here, use in here dot name, and also you can simply uncomment this thing too. Execute our application, open up the logcat, just delete this thing and re-execute it. See over here, app module engine. That means at the rate entry point annotation is also working. So you can use these two approach to inject certain dependency in a component where Android entry point won't work. Now we will discuss few annotation using which you can define your model classes scope. So open up this transmission and here we have a lot of annotations. So you can use here singleton. So it is equivalent to singleton component. We have here activity scope, so it is equivalent to activity component. We have here activity retain scope, and also we have here fragment scope, we have here ViewModel scope. So basically if you want to define the scope of your data class, you can do that thing very easily by using this certain annotation. Two more annotation left, which is IntoSet and IntoMap. So let's see what is the use case of this annotation. So for that I'm going to create a module, and the module name is IntoSet module. Install this thing in a singleton component. This is a module, so simply use here module annotation. I'm gonna create here function provide first string. Return type of this thing is string and it will provide first string. Duplicate this thing, rename this from provide first string to provide second string. Now I want to provide this thing. Similarly I want to provide the second string and also change this thing from first to second. Now here I want to use IntoSet. Okay, so we have here two string, first string and second string, and on top of each provide first provide second string we have IntoSet. So the primary goal of IntoSet is if you want to create a set or if you want to inject the set of the same type, then you can use IntoSet annotation on top of your functions which you want to include into the set. So let's see in the main activity. So here in the main activity I'm gonna perform field injection, let init variable set string, set of string. Now use it over here. In place of name I'm using set string join to string. Execute it. Here you can see we have hello second string first string. That means if you want to create a set of the same type, then you can use IntoSet. Now I'm going to show you what is a use case of IntoMap. So for that let's create one more module. So this is an object IntoMap module. I'm going to copy the same things from here into map module and paste in here. Instead of using IntoSet I'm using here IntoMap. So because map has two things, key, value. So in place of key you should use here string key and pass the key. So use here first. Similarly copy this stuff, remove this IntoSet and paste IntoMap. In place of key I'm using here second. Now go to the main activity. Use here let init variable IntoMap string, map of string. Remove this set string, use IntoMap string. Use your values and join this thing in a form of a string. Execute it. Okay, so I forgot to add here install in singleton component class.java and the module annotation. Now re-execute our application. You can see over here hello first string second string. Now instead of values, if you hover with keys, we have first second, and when you open the IntoMap module we have first and second as key of the map. Now we have only one annotation left, and that is reusable. So reusable is pretty much singleton annotation, but there is a large difference between them. Reusable component is actually cached by our Dagger so that it can reuse that thing again and again in our project. Singleton component will eventually tied up with application lifecycle. So this is the main difference between a reusable and singleton component. So if you want to use a reusable, you can simply use annotation reusable. So that's it for this video. I hope you enjoyed a lot. This video contains all of the necessary information that you should know regarding the Dagger Hilt dependency injection framework. We will meet in our next video. Till that, if you are having any doubt, any suggestion, you can write those things into the comment box. We will meet in our next video. We'll discuss something new about Android. Till that, goodbye.